Come to the video. So in this video we will going to talk about the addition of water and alcohols to aldehydes and ketones. So in general, alcohols and water are not a good nucleophile, rather they are a relatively good living groups. So first of all, generally water and alcohols are weak nucleophiles. Weak nucleophile. So how we could add them on aldehydes and ketones? So first of all, let's suppose we have a aldehyde or ketone. We need to increase the electrophilicity of this carbon group. So in most of the cases, we add water or alcohols in acidic medium. Yeah, we can also do in the basic medium, but we will right now just talk about introduction of this topic. So in acidic medium, let's suppose if I just add H plus, now this lone pair of oxygen will take this proton and the oxygen get a positive charge, and we all know that the positive charge on electronegative atom is not so really stable. So what it does basically, it start withdrawing electrons via inductive effect from this carbon, and hence this carbon is now more electrophilic. So on adding water to it, the lone pairs of water basically attacks at this carbon, and the breakage of pi bond take place. Here the water oxygen gets a positive charge. Now again we need to regenerate the proton, so oxygen gets electron and releases the H plus ions in the solution. So here we just got this compound, and this is hydrate because we have just added the water in it. So this is the first thing that we can do it on, like adding H plus as a catalyst. It just increases the electrophilicity of carbon group. But if we just add some kind of electron withdrawing groups here, just a second, electron withdrawing groups. So basically these electron withdrawing groups again increases the delta plus on this carbon, which increases the electrophilicity of carbon group, and hence we'll see that the reaction take place in a good amount. For example, okay, if we have let's suppose any group, we can place here R, and this is again R dash. On adding water, we'll have this hydrate formation. For this reaction, we can just express the equilibrium constant. So first of all, if we just take first compound, which is acetone, on adding water to it, we got this compound, this hydrate. Its equilibrium constant is around 0.001 equilibrium constant value. Okay, I just write it like with a symbol K, equilibrium constant. Okay, in the next example, if I just remove this CS3, which is electron donating group, and addition of just hydrogen. Now this is acetaldehyde. This acetaldehyde have equilibrium constant value around 1.06. It is way more than this acetone, because we have just removed this CS3 group, electron donating group, and we can see a huge change here. Again, in the next step, next reaction, let's suppose we have another compound which is formaldehyde. For this reaction, we have equilibrium constant around 2280. It is really more. Again, a few more examples. Suppose we have this compound CaCl3 and here hydrogen. This is chloral, common name. Again, on adding the compound, we got this chloral hydrate. It have equilibrium constant around 2000. On just increasing the electron withdrawing groups around this carbonyl, let's suppose we have CF3 here and again CF3 here. This compound is hexafluoroacetone. Now again hydrate is formed. We just see that the value of this equilibrium constant is 1.2 into 10 to the power 6, very huge. So as a conclusion, we can just add that if we increases the electron withdrawing groups here, now the equilibrium constant value in general increases, which means the electrophilicity at this carbon group increases, which helps us during this reaction. Similarly, the similar thing we can see on addition of alcohols. Okay, so let's suppose if we just add uh, 1 mole of alcohol or 1 equivalent of alcohol, let's suppose we have this compound. On adding alcohol in acidic medium, now similar reaction take place. The very first step is a protonation of the carbon group. The H plus basically adds on this oxygen lone pair attacks on H plus, takes the proton, which increases the electrophilicity of this carbon group. In the next step, alcohol oxygen attack to this carbon group and the breakage of this pi bond take place. Again, this oxygen got a positive charge. Next step includes the removal of proton, which makes the regeneration of our catalyst H plus. Okay, so here this compounds are formed having OR group and OH group, called as hemiacetal. If R dash is hydrogen, then this compound would be hemiacetal. And if this R dash would be any hydrocarbon group or alkyl or aryl, then this compound known as hemiketal. Okay, so thank you for watching the video. I hope you got some answers for the topic of addition of alcohols and water to aldehydes and ketones. Basically, both the alcohols and water are not a good nucleophiles, so we need to increase the reactivity by using H plus as a catalyst, or by increasing the electron withdrawing groups around that carbon bond. Thank you for watching the video.